Okay, I'm going to do 3 examples of solving rational equations. Rational equations are equations where the variable is in, or a variable expression is in the denominator. So x is in the denominator. There is x plus 10, x, so on. Okay. If you have not already done so, go ahead and pause it and make sure to read these steps here. All right. Perhaps you should write them down, but at the very least, read them. All right. So, all right, I'm going to jump right in now. Actually, I say that, but before I do that, if you have trouble with this step here, finding the LCD, just go ahead and do a YouTube search of finding the least common denominator. Look for videos on YouTube. So if you do that, if you notice, here's a bunch of videos. Now some of them are just for numbers, but if you scroll down and poke around, you'll find stuff like this one right here might be pretty good about doing pretty hard ones. All right. There you go. Just search for that. Because if you're having trouble finding the least common denominator, then this section will be virtually impossible. And then you probably had a lot of difficulties in the earlier sections as well in this chapter. Anyway, so let's go ahead and now let me jump right into the first example, which you maybe have already tried before. Now, this was actually up on the board in class. Now, the LCD, the least common denominator, is x. So you multiply all 3 parts by x. So x goes here. Ooh, see if I can squeeze that in. X goes here, and then the entire thing is multiplied by x, so I better put an x on the outside there. Like that. Alright, now why do I do that? Well, cancel, cancel. It really is the simplest thing, or the easiest thing. If you multiply the least common denominator, it's the simplest thing that will cancel every denominator. Alright, boom. Let me see. Oh, that's not working. But that's what happens here. Okay, that's the whole idea with this technique, which multiplying every fraction, every part by the least common denominator. Alright? So then what you get is a no, this is step 3 that basically I just did. Crossing stuff out is the simplifying part. And so what you get is an equation that is doable. It's something that should be something that you've seen before. Now notice, so I have the 3x on the right. Okay, so there's not cancellation that happens for everything necessarily. And then this is just kind of standard algebra 1 equation. So you solve this, and then you end up with, if you solve this equation, you get -4 is 2x, so x is -2. Okay? And so then what you have to always do is check and make sure that your answers are legitimately answered, because there is a step, and it's actually this second step here, where you potentially are introducing something that will seem like an answer but is not really an answer. Alright, and we'll talk more about that tomorrow, or in class at least. It's called an extraneous solution, and it's one that seems like a solution. It's kind of a bad name because it's not really a solution. It seems like a solution when you solve the problem, but when you try to plug it back into the original equation, it doesn't really work. Alright, and so if you do that here, if you plug in the -2, you should get something that actually works out. Alright, so if you plug in -2 into here, Brad have a clone, there we go. Plug in -2. If you crunch the numbers, it should work out to be correct. Okay, you end up with like a half minus -2.5, which works out to be 3. It works out correctly. I'm not going to take the time to show that because that's something I know you guys can do on your own. But you take this number here and plug it in, basically making sure that it works out still. Alright, so let's do this one. This one's harder, as one might expect. There are different denominators, so it takes a bit to figure out what the LCD is. Alright, the least common denominator, what is it? Alright, first problem was clearly just x because it was the only denominator. So what you do, let's see, number-wise, you break it down into manageable parts. Number-wise, the LCD should be 24. Alright, 8 and 6 both go into 24, so the least common multiple of those is the least, and I'm not on a pin anymore. Alright, LCD is 24. Now it's not 24 by itself, It's 24. You also have factors of x, so you have your 24x. And remember, it might be helpful to think of the LCD as being, it really is the simplest thing that will cancel out all the denominators. Alright? The least common denominator. If you get a common denominator, it should, and that looks horrible. But the least common denominator, okay, that looks a little better, is 24x. Okay, it's the simplest thing, they'll cancel out everything. So actually, let me clone this, and what we do is we put the 24x everywhere. Okay, so let me go ahead and I'm just going to be, I feel like my handwriting is really bad today, so I'm going to like kind of cheat a little bit. And there we go. So 24x. Okay, and that goes with all three parts. So boom, boom. So 24x, 24x, 24x. Oh, that's perfect because it covers that. Okay, 1 times 24x is 24x. So 17 times 24x, da, 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 da. And the thing is, you don't have to do, you might be thinking, oh no, 17 times 24, we don't get calculators, boo. That's fine, because stuff's just going to cancel, right? A lot of stuff's just going to cancel, actually. The 24's cancel completely, boom. Okay? 24, the x's cancel completely in this fraction. And I missed. In this fraction, the x's completely cancel. In this fraction, the x's completely cancel. And then we can reduce the numbers. In fact, I'll just do that on the next step here. Okay, number-wise, well, let me get you out of the way. I guess I'll do it. So 24 and 6 becomes 4 and 1. 24 and 8 becomes 3 and 1. Alright, so what's left over? So there's x, 17, so what do we get? We get 4 times 5 is 20. This one's actually not too bad. It's harder, the only the reason why it's harder at all is finding the LCD. Minus 3 equals 17x. So it looks like x is going to have to be 1. Okay, notice it's turning it into a problem that is much less difficult. Okay, when you do that. Okay, it usually turns into some sort of linear equation, maybe a quadratic equation, which you should be able to solve. Alright, so let's see, let's check it. And basically, really, ultimately, what you need to be concerned with is make sure you can plug it in at all, to be perfectly honest. That's what you got to make sure that you can do, because generally, if you can plug it in, it should be a solution. Alright, and so if you plug in 1, yeah, you get, it's okay. Right, the only number you can't plug in is 0. Remember, the domain would have to be everything except 0. Right, you can have domains of equations just like we have domains of functions that works basically the same. Alright, same idea. You can't plug in 0. That would be dividing by 0. The only thing we're concerned with is 1 though. We can plug in 1. And if you plug in 1, it should work out to be 5, 6 minus 1/8 equals 17 over 24. Should work out. Boom. Last but not least, this guy. The hard part here, again, is finding the least common denominator. Alright, I'm trying to draw right with the mouse. It's really no better. Alright, so LCD equals, well, we need a 2 and an x. And then we need an x plus 10. Okay, so for the harder problems, and we'll do those together in class, you've got to do some factoring and figuring out what, you've got to figure out what the factors are, because you basically just put all the factors together. Okay, so let me clone this again. Make this really big because the LCD is long. Alright. Okay, and so this right here goes with all three things. Okay, our friend the LCD, clone. Okay, in all these problems there's been like 3 parts, and that's not always the case. It could be longer, it could be shorter. So 1 times the LCD, boom, I'll just put that away, or put that on top. And let me see if I can squeeze this sucker in. It's 50 times the 2x plus 10. Squeeze it in there. Alright. So there we go. What cancels? Time to cancel some stuff out. Let me use a different color maybe, if I can click on it. Alright, so x and x, those cancel. Okay, x plus 10 and this x plus 10 here cancels. Only the 2 and the 2 cancels. Okay, so now what? Let's start figuring out what this is going to look like. And so 2 times 30 times x plus 10, if I multiply that out, and it would be wise to do so, you get 60x plus 60. Wait, yeah, 2 times 30 is 60, distribute both of this, it's, oh my, no, it's 60x plus 600, that's quite large. Alright, equals, let's see, 100x plus x squared plus 10x. Okay, and so what we have here is a quadratic equation. Okay, quadratic equation, we've talked about how to solve these, let's go ahead and do it. Alright, so we have to get all, this is complicated looking, we have to get everything over on one side. I will subtract 60x and subtract 600. We're going to combine some like terms. You should get 0 equals x squared. It's going to be plus 50x okay, minus 600. Okay, which is crazy huge numbers. That's alright. Okay. If you factor this, and you're just going to have to bear with me, these numbers are pretty huge. It's alright. If you factor this, you get things that multiply to make 600 negative, I should say, negative 600, add to make 50, are plus 60 and minus 10. Ooh. Interesting. Minus 10. Alright. Okay. So you could also use the quadratic formula if you wanted to. But this does factor. So you said each factor equals 0. X plus 60 equals 0. So x equals negative 60. X minus 10 equals 0. So x equals 10. Okay, so we have two solutions. Maybe. Okay, so now what we have to do is go back to the top, and I like working on this ginormous equation. I'll call him that guy. Alright, so we have to go back and think about the original problem and say, hey, do these numbers actually work? And, oh, I'm silly. I thought there was going to be an extraneous solution, but no, they both should be just fine. If you plug these in, they both work. So they are both solutions. I was thinking the problem was a minus 10, and that would be something you cannot plug in. The domain of this equation is everything except for 0. If you plug in 0, you divide it by 0, that's bad. And if you plug in negative 10, you divide it by 0, and that's also bad. So, but this is a positive 10, so we're good to go. Alright? Had this been a negative 10, this would be what would be called an extraneous solution, something that does not actually work. Alright, but we're good. Oh, wait a second.